Hey, Math 20-2, today we're going to look at the ambiguous case of the sine law. Ambiguous means not guaranteed. Alright, students were asked to determine the measure of angle ACB in a triangle in which AB is 6, AC is 4, and angle ABC is 30 degrees. Two students, Scott and Brittany, each constructed triangles to represent the given information. Scott's is on the left, Brittany's is on the right. Use a ruler or protractor to confirm that each student's triangles correctly represents the given information. It does. They both correctly represent the given information. Both AB are 6 centimeters, AC is 4 centimeters, and angle ABC is 30 degrees. Without using a measuring device, estimate to the nearest 10 degrees the measure of angle ACB in each case. So let's estimate that angle there and this angle over here, and we can tell they're definitely not the same angle measured. So I would think in Scott's case, it's probably a little bit less than, well, I mean, it might be exactly the same. It looks very similar to this angle, so let's say maybe it's 30 degrees. And in Brittany's case, it is way more than 90, right? So I mean, 110, 120, 130 degrees, somewhere in there would be a good guess. The work for Scott's diagram and for Brittany's diagram is identical in the first 4 steps as shown. So if we use our sine law and we substitute into this properly, the sine of angle C over side C equals the sine of angle B over side B. So I know the measure of side C is 6 in both triangles. I know the measure of angle B is 30 degrees in both triangles. I know the length of side B is 4 in both triangles. So we do the exact same calculation and we get the sine of C is 6 times the sine of 30 divided by 4, right? Multiply both sides by 6, so 6 sine 30 divided by 4. If you do that calculation, you get the sine of 30 is 0.75. So it doesn't matter which triangle we did, we're going to get that exact same set of work for both triangles. The sine of C equals 0.75. Now we get 2 different angle measures here, right? So that's interesting how they could be the same. In Scott's case, if I use the inverse sine, determine the nearest degree of the acute angle ACB whose sine ratio is 0.75. So let's do that. Second function sine of 0.75. And we get about 49 degrees. So angle ACB in Scott's case maybe is closer to 49 degrees instead of 30. In Brittany's case, use guess and check on your calculator to determine the nearest degree, the obtuse angle ACB whose sine ratio is 0.75. So what they're asking us to do is, let's take the sine. We know the sine of 49 degrees is about 0.75. We just calculated that. But we need an obtuse angle, right? This angle is an obtuse angle right here. It's greater than 90. That's the definition of obtuse angle. So let's start thinking of some angles that are greater than 90. Obtuse angles, greater than 90, that have a sine ratio of 0.75. So by guess and check. So if I want the sine of 100, that's greater than 90. The sine of 100 is 0.98. All right, let's try the sine of 110. That's 0.94, so we're getting closer to 75. We thought it was about 120. That's 0.866. That's not 0.75. Let's try the sine of 140. Oh, sorry, 130. Keep going by tens here. And that gives me 0.766. That's pretty close to 0.75. So maybe now let's go with the sine of 135. That's 0.707. So it's got to be somewhere between 130 and 135. And this is the guess and check method, right? So maybe you do 131. And that's pretty close to 0.75. So the nearest angle we're going to get is 131 degrees. That's an obtuse angle who's got the same sine ratio of 0.75. Calculate the measure of angle CAB in each case. So now they want to know what these angles turn out to equal. All right. So in Scott's case, for Scott's triangle, that's angle A. We'll just call it angle A. All right. In Scott's triangle, to find angle A, we should say the sum of the measures of the angles in the triangle are 180 minus, we were given an angle of 30 degrees and we figured out an angle of 49. So angle A in Scott's triangle, 180 minus 30 minus 49 is 101 degrees. If we look at Brittany's triangle, angle A should be 180 degrees minus, we're given 30, and we calculated the other one to be not 130 but 131. 131 degrees. So angle A angle A in Brittany's triangle is 180 minus 30 minus 131. That's about 19 degrees. In this particular example, the information given allowed us to draw two different triangles, which produced two different answers to the same question. This is an example of the ambiguous case of the sine law. Right? When you get to this situation right here, we've got two possible angles that give us that ratio, and the two triangles we drew both satisfied the sine law, so we had two possible solutions. Scott's triangle worked out, and so did Brittany's triangle. They both worked out. All right. That's not always the case, but sometimes that happens with the sine law, and we call that sometimes the ambiguous case. How do we know if given information will produce a unique solution, meaning one, or two different solutions, like the ambiguous case? The work that follows will help us determine the answer to this question. Let's investigate the sine ratio for acute angles and obtuse angles. The graph of y equals sine x between 0 and 100 degrees is shown. All right. Now, you might say, where does that come from? Well, let's just draw quickly in our graphing calculators and we can get the exact same thing. So if you go to y equals and type in sine x, and I'm not sure what I've got going here, but I'm going to clear these, turn these plots off so I don't have more than I wanted here. So there's y equals sine x. Make sure we have the same window setting that we have in our notes. So let's go to our window. And on our notes, we've got x going from 0 to 180. So maybe let's go a little bit less. Maybe let's go from negative 30 to 210, just so we can see. And in our notes, it went by every 30 degrees. We've got a little scale there. Actually up by every 15, but they marked 30s. And our y-axis goes from 0 to 1. But we want to see below that. Let's go negative 0.5 to 1.5 by a scale of, they went up by 0.25. All right, so now if I graph it, we get the exact same picture we have in our notes. All right, so there's our sine x function. To solve the equation sine x equals 0.75, we can graph y1 as sine x and y2 as 0.75 and use the intersect feature of the graphing calculator. So this is y1. That's already graphed for us, y1. If I want to graph y2, it should be at 0.75. That's the graph of y2. equals 0.75. And use the intersect feature on the graphing calculator. So here's one point of intersection, here's another point of intersection. Ideally, those 2 points of intersection should be 49 degrees and 131. So 30, 45, 60. So yeah, that's about 49. And 120, 135, 150. So it's supposed to be at 131. So I mean, we're pretty close with that. Let's do it on a graphing calculator and see if we actually get 49 and 131. So let's go into y equals, go down to our y2 and type in 0.75. Hit graph. There's the line, y2 equals 0.75. Now let's go second calculate. They told us to use the intersect feature, which is number 5 on our calculator. And you just have to hit enter for the first curve. Notice in the top right hand or top left hand corner of your screen it says y1 equals sine x. That's what the cursor's on. Press enter. The second curve is y2, 0.75. Excellent. We want to find the intersection between those 2 points. Let's make a guess. Sure, let's guess over here. And that looks to be pretty close to 49 degrees. X is 48.59 or 49 degrees. Let's do it again. Second calculate the point of intersection number 5. First curve, sine x is y1. Second curve, 0.75 is y2. Let's make a guess. We want to figure out this point of intersection over here now. And that one looks like it's pretty close to 131 degrees, 131.4. So it does check out. All right. So on this grid we can see there's 2 solutions for sine x equals 0.75. There's one solution, there's the other one. 49 degrees and 131 degrees. 2 solutions. Example 1 then. Use the symmetry of the graph of y equals sine x to explain how to get the obtuse angle solution from the acute angle solution without using guess and check or the intersect feature of a graphing calculator. Well, because they are symmetrical, all right, the 2 angles should be supplementary. And we know what that means. They sum to 180. Sum to 180 degrees. That's what supplementary means. So state an obtuse angle whose sine ratio is the same as the sine ratio for the following. So if this angle is 20 and they have to be supplementary, the other angle is 160. You want to check. Let's see if that's right. Let's go to this graph and let's go sine of 20 and the sine of 180 minus 20, which is 160. Exact same values. All right, that's the symmetry of the sine graph. Those angles must be supplementary. So if one angle is 80 degrees, the other angle must be 100. They're going to have the same sine ratio. If one angle is 13, the other one's going to be 180 minus 13, which is 167 degrees. And if one angle is 38.6, the other one's going to be, that's 39, that's 40, that's 80, that's 180. 141.4 degrees. All right. Part C, determine 2 solutions, one acute angle and one obtuse angle for each of the following equations. Answer to the nearest degree. So the acute angle solution, let's go to our calculators. If the sine of x is a half, on our calculators, I would simply go second function sine of 0.5. And that's going to always give me the acute angle measure of 30 degrees, the acute angle measure. In this case, it's 30 degrees. So the sine of x is a half. X as an acute angle should be 30 degrees. X as an obtuse angle would be the supplement of 30. So 180 minus 30 is 150 degrees. If you want to check in your calculators, go sine of 30, well, that's 0.5, and the sine of 150 should also be 0.5, and it is. So both those angle measures, 30 and 150, have the same ratio of a half, or 0.5. All right. Sine of x is 0.788. How do I find out what the angles could be? I go second function sine of 0.788. And the calculator will always give you the acute angle. That angle in this case is about 52 degrees. So that's a 52-degree angle. But there's an obtuse angle that also makes this equation true. So that would be the supplement of 52, so that is 128 degrees. And again, if you'd like to check, we can do that. The sine of 52 and the sine of 128 are the exact same ratio, right? So that only happens for the sine ratio for obtuse and acute angles. So the sine of x is 513, so let's figure out the acute angle. Second function sine of 5 divided by 13. And that angle's 22.6 to the nearest degree, 23 degrees. Well, the obtuse angle that also satisfies this equation would be 180 minus 23, or 157 degrees. And the last one, sine x is 7/25. Second function sine of 7 divided by 25. We'll get the acute angle. It's about 16 degrees. We can figure out the obtuse angle because it's a supplement of 16. 180 minus 16. Well, there's 120, 180, sorry, 20, 80, 180, 164 degrees. All right. Investigating conditions for the ambiguous case of the sine law. The possibility of an ambiguous solution only exists if the given information is of the type side-side angle. In other words, you know two sides and an angle not contained between the first two sides. That's the only time that an ambiguous case may exist. Often the context of the question or the diagram provided makes it obvious to the solution whether it's going to be an acute angle or an obtuse angle. If it's not obvious, then there are two possibilities depending on the value of the angle given. So you can either have exactly one solution, or you can have your two solutions where you've got one acute angle and one obtuse angle that are supplementary. When solving for the required angle on a triangle using inverse sine, the calculator will only ever provide the acute angle. We saw that last question. We would have to figure out the obtuse angle by subtracting it from 180 because they're supplementary. Note the three angles of a triangle always add to 180, but if the given angle added to the obtuse angle is greater than 180, then the obtuse angle solution is not possible, and therefore there is no ambiguous case. That's how you know if that second one doesn't work. So let's complete the table below. For a situation where one angle has been given and an acute angle has been calculated using the sine law, the first line of the table is the information from Scott and Brittany's example. So we were given an angle of 30 degrees. We found the acute angle of 49 and the obtuse angle of 131. If you're given 30 and you find one angle of 49, then the third angle has to be 101. If you're given 30 and we use the obtuse angle of 131, then 30 plus 131 plus 19 is our second triangle. All right, so that's how this chart works. So if you're given an angle of 25 degrees, we find the acute angle 33 degrees. The third angle in that initial triangle should be 180 minus 25 minus 33. So 180 minus 25 minus 33 is 122 degrees. However, given the acute angle 33, we can come up with an obtuse angle that's supplementary to 133. So 180 minus 133 is 147. So now I have a given angle of 25. I've got an obtuse angle of 147. What's the third angle in that triangle? Well, that's 180 minus 25 minus 147, which gives 8 degrees. So again, that triangle has two possible answers, or that information has two possible answers. Let's look at the next line. You're given an angle of 30 degrees. You find an acute angle of 24. What is the third angle in that triangle of 30 and 24? So 180 minus 30 minus 24 is 126. Now we could also get an obtuse angle. Given 24 degrees, the obtuse angle would be 180 minus 24. 180 minus 24 is 156. Now figure out the third angle. If you've got 30 degrees as a given angle, an obtuse angle of 156, what would the third angle be? Well, 30 and 156 is 186. You can't figure out a third angle that's going to add up to 180 without being negative, so that's going to be not possible. All right. So the given angle of 30 and the obtuse angle of 156 add up to more than 180, so there can't be a third angle in the triangle. Therefore, you can't get that second possible triangle. So the next one, given 25 degrees and an acute angle you find of 21 degrees, what's the third angle of that triangle? Well, that adds up to 46. There's 50, 80, there's 180 degrees. So the third angle is 134. But given 21 degrees, we could also figure out the obtuse angle that's supplementary to that acute angle. 180 minus 21 is 159. Now if I look, we were given 25 and I've got 159. What's the third angle in that triangle? 25 plus 159 is more than 180. So this is also not possible. So there's only one possible solution in that situation. Second last one, given an angle of 54 degrees, you find an acute angle of 43. The third angle must be 180 minus 54 minus 43. So that gives us 83 degrees here as the third angle in that triangle. Now, if I have an acute angle of 43, I could have an obtuse angle. That would be 180 minus 43, which is 137. And the third angle in the new triangle, given 54 and an obtuse of 137, that adds up to more than 180, so we can't have a third angle. So that means there is no possible triangle that satisfies the second scenario. Let's look at the last one. Given 54 degrees, you come up with an acute angle of 64. The third angle in that triangle will be 180 minus 54 minus 64, which is 62 degrees. So that's one possible triangle. If you have an acute angle of 64 degrees, we could have the supplementary angle giving us the obtuse angle of 116 degrees. All right, 64 and 116 up to 180. So you now have a triangle that has 54 degrees in it, 116 in it. What's the third possible angle? Well, 54 and 116 adds to 170. So this one does work if that third angle is 10 degrees. So if I look at all the situations, I've got three cases where I've got two possible solutions. One, two, those three cases have two possible triangles. And these three cases do not have two possible triangles. They've only got one possible solution. All right. The determining factor is how the calculated acute angle compares to the given angle. So look at these two columns, how the calculated acute angle compares to the given angle. If you look at that, we can decide whether you're going to have two solutions or only one solution. So if the acute angle is greater than the given angle, if this acute angle is greater than the given angle, 49 is greater than 30, 33 is greater than 25, and 64 is greater than 54, there will be two solutions. However, if the given angle, the acute angle is smaller, 24 is less than 30, 21 is less than 25, 43 is less than 54, then there's only one solution. We can't get a second solution. All right. So let's look at example 2. Excuse me. Find all possible measures of angle C in the following triangles. So a triangle ABC where angle A is 50, little a is 7.5, and little c is 9.5. Maybe let's try and draw a diagram that might satisfy this thing. Alright. Again, this is not to scale. Angle A is 50 degrees. Little side A is 7.5. And little side C is 9.5. Maybe we'll make this side C. So there's triangle ABC. Find the measure of angle C. We're looking for this angle. So I got a complete ratio. I know angle A and the side opposite that. So let's do our complete ratio. I'm going to say the sine of 50 degrees over 7.5, sine of A over little a, equals the sine of angle C over little c, 9.5. So I can now find the sine C by multiplying both sides by 9.5. So 9.5 times the sine of 50 divided by 7.5 will give me sine of C, or I can figure out what angle C is using my calculator. So let's do that. So I would say 9.5 sine 50 divided by 7.5. 9.5 sine 50 divided by 7.5. And again, we're going to get a ratio. Actually, a second function sine of that ratio to figure out the angle. 76 degrees. So angle C is 76 degrees. So I know I have one complete triangle. Alright. If angle A is 50 and angle C is 75, I can figure out angle B. Alright. Like we did last slide. Or last page. So let's see what that would be. Angle B would be 180 minus 50 minus 76. 26, 130, 180. So angle B is 54 degrees in that scenario. However, is it possible to have another measure for angle C? We could have angle C equaling 180 minus 76, the supplementary angle. So 180 minus 76 is 104 degrees. Right? If you wanted to check that out, if we said the sine of 76 and the sine of 104 give us the exact same ratio, so the other angle could be a 104 degree obtuse angle. So from that angle, what would the possible third angle be? Well, let's figure out what angle B would equal if angle C is 104. 104 plus 50 is 154, and you can subtract that from 180. So angle B could be 26 degrees. So I've got two possible angles, therefore, or two possible triangles that both work. There I've got two possible values for C. C could be 76 degrees, or C could be 104 degrees. So this is the ambiguous case. So if we looked, the acute angle we found is greater than the angle that was given to us. 76 is greater than 50, so the ambiguous case worked. All right. There were two possible triangles. Let's go over to example B. Triangle ABC. So again, let's draw this one, where angle A is 50 degrees. Side A is 9.5 and side C is 7.5. So now let's do this one. So we've got the exact same scenario. We're looking for measures of angle C. Oh, but I wrote that wrong. This should be C. Sorry. Side C is 7.5, so angle C is opposite side C. So we're looking for angle C. Same thing. So we've got one complete ratio. The sine of angle A, which is 50 degrees, over the side of angle A, which is now 9.5, should equal the sine of angle C over the side opposite C, which is 7.5. I multiply both sides by 7.5 divided by 9.5, and I can figure out the measure of angle C. So let's do that. 7.5 sine of 50 divided by 9.5. We get that ratio, second function second function sine of that answer is 37 degrees. All right. So angle C is 37 degrees. That means we can definitely have an angle B. All right. So if A is 50 and B and C is 37, then C would equal, that's 87, 90, 180. Angle B is 93 degrees. So that's one possible triangle. Let's see if the ambiguous case works. According to our rule, the acute angle we found was 37. That's less than 50. There should not be an ambiguous case. But let's figure it out just to make sure it doesn't work. Angle C could also be the supplement of 37. So 180 minus 37 is 143. And now if I go 143 plus 50, that's 193. Angle B is not possible. So in this case, it was not the ambiguous case. Only one solution. Right. Only one solution. Angle C could only equal 37. The ambiguous case did not apply. Okay. So there's your assignment. Let's get after it.